So we discussed about the adjunct of a matrix. Sometimes it is referred to also as the adjunct of a matrix. So let A equal to Aij be an n by n matrix. The adjunct of A, denoted by Adj of A, is an n by n matrix whose ijth element is the Aj cofactor of A. Alright, so we start with the matrix A, which is n by n. We will determine all the cofactors of the elements of A. We form the n by n matrix where the ijth element will be the cofactor Aj. Alright? So, for example, let me use a clear screen. So, for example, we are given matrix A, which is a 3 by 3 matrix. 1, 0, negative 1, 1, negative 1, 0, 0, 1, and let me see, say 1. Let me check it first. What is the determinant of A? I have to make sure that the determinant is not equal to 0. So it will be negative 1, and then 0, minus 1, 0, 0, and 0. So it should be negative 2. Okay? So again, negative 1, 0, negative 1, 0, 0, and 0. Okay. So since it is a 3 by 3 matrix, there will also be as many as cofactors as elements in matrix A. Meaning to say, if it is a 3 by 3 matrix, there will be 9 elements. And likewise, there will be 9 cofactors. So let us calculate each of these 9 cofactors of matrix A. So we start with A11. Remember the definition of the cofactor? A11 is equal to negative 1 raised to 1 plus 1 times the determinant of, delete the first row, first column. So we'll be getting negative 1, 0, 1, and 1. We delete the first row and first column. Negative 1, 0, 1, and 1. And we'll do that for all the elements. So let us go now to, okay, let us calculate this. So negative 1 raised to 2 will be positive, and then negative 1 minus 0 is negative 1. Let us go to A12. It will be negative 1 raised to 1 plus 2 times the determinant of. Delete the first row, second column. So we'll be getting 1, 0, 0, 1. Delete the first row and second column. 1, 0, 0, 1. So that will give us negative 1 raised to 3 is negative. And then the determinant of 1, 0, 0, 1 is 1. Next, A13. Negative 1 raised to 1 plus 3. Determinant of. Delete the first row, third column. That will be 1, negative 1, 0, and 1. So let us check that. We delete the first row and third column. 1, negative 1, 0, and 1. And negative 1 raised to 4 is positive. Determinant is 1 minus 0 or 1. Next, a to 1. Negative 1 raised to 2 plus 1. Determinant of. Delete the second row, first column. So that should be 0, negative 1, 1, and 1. We check. We delete the second row, first column. So 0, negative 1, 1, and 1. That will be negative 1 raised to 3 is negative. Then 0 minus negative 1 is positive 1. So that will be negative 1. Okay? Then we go to a to 2. Negative 1 raised to 2 plus 2. Determinant of. Delete the second row, second column. 1, negative 1, and 0, 1. Delete the second row, second column. 1, negative 1, 0, and 1. And negative 1 raised to positive 4 is positive. Determinant is 1. Next, a to 3. Negative 1 raised to 2 plus 3. Determinant of. Delete the second row, third column. 1, 0, 0, 1. Second row, third column. 1, 0, 0, 1. Then A31, negative 1 raised to 3 plus 1, determinant of. Delete the third row, first column, 0, negative 1, negative 1, 0. Third row, first column, 0, negative 1, negative 1, 0. That will be negative 1 raised to 4 is positive. And then the determinant is 0 minus 1. That will be negative 1. Then A32, negative 1 raised to 3 plus 2. Determinant of third row, second column. 1, negative 1, 1, 0. Third row, second column. 1, negative 1, 1, and 0. Then lastly, we have A33, negative 1 raised to 3 plus 3, determinant of third row, third column, 1, 0, 1, negative 1. Third row, third column, 1, 0, 1, negative 1. So by the way, what is my A32? Negative 1 raised to 5 is negative. And then the determinant is 0 minus negative 1. So that is positive 1 times negative, negative 1. Okay? And for A33, negative 1 raised to 6 is positive. Determinant is negative 1. Alright. So we now have all the cofactors. No? A11, A12, A13, 2-1, 2-2, 2-3, 3-1, 3-2, and 3-3. So we are now ready to write the adjunct of the matrix A. So the adjunct of matrix A is the 3 by 3 matrix whose elements are the cofactors and then transpose. No? So let us write down all the cofactors. Negative 1, negative 1, 1, negative 1, 1. By the way, what is our A23? What is our A23? Negative 1 raised to 5 is negative, and then the determinant is 1. So it should be negative 1. So negative 1. Then A31 is negative 1, negative 1, and negative 1. Okay? So let me free up some space. Okay, so that is my adjunct of A, but I need to take its transpose. No? So the adjunct of A is equal to, the first row becomes the first column. Negative 1, negative 1, 1, negative 1, 1, negative 1, negative 1, negative 1, and negative 1. Right? Okay, at this point, let us determine what will be the product of A and its adjunct. Let us find the product of A and its adjunct. So let us rewrite our A. So A times the adjunct of A. So our A is 1, 0, negative 1, 1, negative 1, 0, 0, 1, and 1, multiplied by the adjunct, negative 1, negative 1, negative 1, negative 1, 1, negative 1, 1, negative 1, and negative 1. Okay. So let us perform multiplication on these two matrices. So 1 times negative 1 is negative 1, 0 times negative 1 is 0, negative 1, and 1 is negative 1. So negative 1 plus 0 and negative 1, that gives us negative 2. Okay? Next, first row, second column. Negative 1, 0, and positive 1, that will be 0. First row, third column. Negative 1, 0, and positive 1. Second row, first column, negative 1 plus 1 plus 0 is 0. Negative 1 and negative 1 and 0 is negative 2. Second row, third column, negative 1, positive 1 plus 0 is 0. And then we go to the third row. Third row, first column, 0 minus 1 plus 1 is 0. Third row, second column, 0, 1, and negative 1 is 0. Then finally, third row, third column, 0, negative 1, and negative 1 is negative 2. And what do we see here? We have a matrix which is a diagonal matrix. Not only a diagonal matrix, it is a scalar matrix. Why? Because the elements along the diagonal are identical. So it is a scalar matrix. And I can write this in a different way. I can factor negative 2 from each of the elements in the matrix. So I'll be getting negative 2 times the matrix 1, 0, 0, 0, 1, 0, 0, 0, and 1. And we recognize this matrix as the identity matrix, right? That is our identity matrix. Okay? So what is this number negative 2? What does it represent? A while ago, right at the start, we calculated for the determinant of matrix A. And we found out that the determinant of matrix A is equal to negative 2. Alright? So it leads us to an important theorem. So the theorem states that if A is a non-singular matrix, or if A is an n by n matrix, then the product of A and its adjunct is equal to the determinant of A times In. Right? That's exactly what we obtained. No? We multiplied matrix A to its adjunct, and we came up with a scalar matrix, which is equal to the determinant of A multiplied to the identity matrix. From this, it will lead us also to a formula that will determine the inverse of a matrix. All right? So, if A is a non-singular matrix, meaning to say that its inverse exists. No? If A is a non-singular matrix, then its okay, then its inverse A inverse exists. All right? So if we are going to multiply both sides by A inverse, what do we get? If A adjunct of A equal to determinant of AIN is pre-multiplied by A inverse, what do we get? The product of A and its inverse is the identity matrix, no? Multiplied to the adjunct of A, equal to the determinant of A is a scalar. So you can write this as determinant of A inverse times the identity matrix. And we know that when the identity matrix is multiplied to any matrix, the result is still the given matrix. So adjunct of A is a matrix multiplied to the identity matrix, or the identity matrix is multiplied to the matrix adjunct A, the result still adjunct A. And in here, we have the determinant of A, which is a constant. A inverse is a matrix multiplied to the identity matrix, which again will result to the identity matrix A to the negative 1. And since the determinant of A is not equal to 0 because it is non-singular, so let us write it down. If A is non-singular, if A is non-singular, meaning to say it is an inverse, then the determinant of A is not equal to 0. Okay? So if it's not equal to 0, we can divide both sides by the determinant of A, and thus we'll be getting the formula one way, or one method of finding the inverse. A inverse equal to 1 over the determinant of A times the adjunct of A. So this is an important relation. We take the adjunct of a matrix A, divide it by its inverse, or rather by its determinant, then it will give you the inverse of the matrix. Okay?